This is an extra video on lesson 4 on finding the center of rotation when one image is transformed or rotated from one position to a second position. How do you find that center of rotation? And this is a topic that's actually covered in lesson 6. But the reason I'm covering it now is in 2 different places in this lesson, students are asked to see what the center of rotation is and use it. So for example, in the first case, you're supposed to see what the center of rotation is between these 2 figures. And this one's not too bad. You can kind of see that it's this pink point right here, and that this is a 90-degree rotation that's counterclockwise. So the center of rotation is right there, but how do you know? How do you figure that out? And the second case is with this image, where students are supposed to rotate B to C, and they are supposed to recognize that R is the center of rotation. And again, once you tell me, I can demonstrate and I can show you that that's a center of a circle, and these 2 images rotate on that circle. So this is the center of rotation. But how do you find it? How are students supposed to find that center of rotation and then use it? So let's go back to this image, this first image. And if I tell you that the center of rotation is right here, I'm going to go through some steps of locating that center. And you're going to see that it points right to that point right there. So the way that you do this, but first of all, I can show you once again that that is a center of rotation. I'm going to rotate the image around. So there's the circle, and the blue image is going to rotate on that circle around and cover the green image. So that is the center of rotation, and it rotates 90 degrees from this axis or this line right here, 90 degrees around this way to this line right here. And this is from the app that's provided by the publishers. And if you take, just make 10-degree increments using the app, you can show that it rotates around the point, and it's a 90-degree rotation. So right here, from this point here to, it looks like I have to go one more, to that point right there. So that is, once again, 90 degrees. All right, so I'm going to go through some steps of finding that center of rotation. And to begin, you take one figure and you take its rotated image and you connect the corresponding points. And so the corresponding points are the points that match in the figure, whether it's rotated or not. So the corresponding point to C is C prime. And we designate the corresponding point with this prime. We're going to keep the same label C, but use prime to tell you that that's the point in the rotated image. And so then we're also going to connect point B to B prime. I am going to do in a little bit A to A prime, but let's just focus on these 2 first. So your first step is just to connect those points with a line segment, C to C prime and B to B prime. And then the next step is in Doceri, and so this is why Doceri is useful. You can locate the midpoint, the middle of that line segment using Doceri. So this line segment here, if you just start to draw it in Doceri and get close to this line segment, it will snap right to the midpoint. This one's kind of nice because it shows you that that is the midpoint just by virtue of this is the diagonal of a square and this is the diagonal of a square. But you find the midpoint. So again, just start drawing a line with Doceri and it will snap right to the midpoint right there. Okay, once you have the midpoint, then you're going to draw a line that's perpendicular to the line that connects the corresponding points. So perpendicular means a line at a right angle. So this line right here that I'm drawing is at a right angle to the line segment that connects the corresponding points. And this line is a right angle that is perpendicular. It's at a right angle to the line segment that connects B to B prime. So you just extend these line segments out towards the center of rotation. You just have to have some idea that you're going in this direction and not the opposite direction. If you tried to go in the opposite direction, they would never intersect. They would continue to go and get farther and farther apart. So you know that this is the correct direction. And they intersect right at the center of rotation, right there. And if you do the same thing with A, and so I'm going to use Doceri once again to locate the midpoint. So the midpoint's right here. And if I draw a line that's perpendicular, so 90 degrees, it's going to go in this direction, and it's going to intersect with this point right here. And so there it is. So all three of these lines that are perpendicular to their line segments that connect the corresponding points all intersect at the center of rotation. So that is how you can locate that center of rotation if it's not given to you. All right, so let's watch a little video here. And you can check that by using this counting strategy. So if it counts, if C is 2 units along the axis in this direction, and B is 1, 2, 3, 4, 5, 6, and then 1 unit, and 1, 2, 3, 4, 5, 6, and 1 unit in the direction of rotation. And A is 1, 2, 3, 4, 5, 6, 7 along the axis, and then 1, 2, 3 in the direction of rotation. And you can see that A again, you rotate 90 degrees, count down 7, then over 3, and you end up in the correct spot each time. So that confirms that that was in fact the center of rotation. Now let's look at the second figure, and we're still going to do this again and again and again, and you will get used to it. So B rotating to C. First of all, that is a 60-degree rotation. So how do you know? I'm going to show you in a little while. But first of all, how do you find that center of rotation? So I tried a few points. I tried this point, and then I hit rotate. This is using the app that the publishers provide, and B rotated to here. So that's not the center of rotation because it has to get to this figure C. Let's try another one. I tried this point, rotated to here. So that's not the center of rotation. So how do you find that center of rotation? You can keep guessing. That's not it. It's getting a little bit closer. Get a little bit closer. And finally, that's it. So you can see this turns a darker shade of green. I'll show you again. Go from B to C. So this is point, what they label point R in the answers. And this goes from B, and this image gets darker, a darker green. So it's rotating to C. And again, I'm using the same app. If I use, I think this was 15 unit increments. I can't remember right now. This might have been 10. The other one I think was 15. So if you rotate this image around, eventually it will fall right on top of C. So that is a 60-degree rotation. I can draw a circle. I can show you that these points lie on that circle and that this image B rotates to image C. Now this midpoint is not on the circle, it's on a separate circle. It still has the same center of rotation, but it's as if that line segment is grabbing this image and rotating it around so it falls on C. So how do I know it's 60 degrees? Because it rotates. This is a 60-degree angle right here. It's an angle within an equilateral triangle. If you rotate this 60 degrees, it ends up in the same orientation, the same direction as C. So that is a 60-degree rotation. But then the task was, how do you find the center of rotation, which turns out to be right here. If you count out 1, 2, and count out 1, 2, you end up at this point. So we're going to go through some steps of how to do that. But you can check it by using this counting strategy. So I'm going to go from the center of rotation to the points on this figure. So I'm going to count up 1, 2, 3, and then I'm going to count in the direction of rotation 1 unit. So now if I rotate this 60 degrees to here, and I count 1, so I'm going to rotate it 60 degrees, count along this axis, I'm going to call it an axis, 3 units, and then in the direction of rotation 1 unit. So you end up in the corresponding position, which tells you that that in fact is the center of rotation. So let's try that again with another point. Count 1 unit along the axis and then 3 units in the direction of rotation. You end up here. Well, that corresponding point is right here. So if I rotate this 60 degrees and count in this direction 1 unit, in this direction 3 units, I'm going to end up in that same point. So I'm going to count in the direction of rotation. So count along the axis 1 unit and count in the direction of rotation 3 units, and you end up at the corresponding point. So that is in fact the center of rotation. And you can go through a series of steps. I could take time to explain this, but you can demonstrate that those are 60-degree rotations, and we can spend some time playing around with that. All right, so let's take 3 different figures, a blue, green, and maroon figure, burgundy or maroon. Let's find the center of rotation for each of these, rotating from the black trapezoid right here. So first of all, it is a 60-degree rotation. I'll show you that in a little bit more detail. So going from this side of the trapezoid, and that's going to rotate around to this side of the trapezoid. That is a 60-degree rotation. So we know the rotation is 60 degrees, but what is the center of rotation? So let's look at just the blue trapezoid rotating from the black trapezoid. All right, so the steps. Once again, I'm going to connect the corresponding points. So I'm going to connect this point with its corresponding point, which is right there. And I'm going to connect this point with its corresponding point, which is right there. Then I'm going to find the midpoint of these 2 line segments. I'm going to use Doceri. All I have to do is get the line segment close, and it will snap to the midpoint. I'm going to show you that in a video. Zoom in a little bit. So that point snapped to the midpoint. So now I'm going to draw a line that's perpendicular. I find this line that's I drew it first, and I'm just confirming it. I'm just stepping down until I have a line that's perpendicular to this line that connects the corresponding points. It has to intersect with, it has to end at an intersection because it's a 60-degree rotation. So I'm just looking for a line segment that's perpendicular to the pink line. And it turns out that they have to intersect. They have the same center of rotation. So you end up at this point down here. So I'm going to get rid of those line segments that I used to find the midpoints. And I'm left with that. So this is the center of rotation right here. And so then how do you prove that that is in fact the center of rotation? I'm going to go through this counting strategy once again. So I'm going to start at this point here. I'm going to count along this axis. 1, 2, 3, 4. And then I'm going to count in the direction of rotation. 1, 2, 3, 4, 5 units. Then I'm going to rotate this 60 degrees to here. And I'm going to do the same thing. The red that we're looking at. 1, 2, 3, 4. Then I'm going to count in the direction of rotation. 1, 2, 3, 4, 5. And I do in fact end up at the corresponding point, which tells me that that was the center of rotation. And I confirm it by doing one more. I'm going to count the green along the axis of the equilateral triangle. So it's 1, 2, 3, 4, 5. Then I'm going to count in the direction of rotation. 1, 2, 3, 4, 5, 6. So rotate this 60 degrees. Count 1, 2, 3, 4, 5, and then count in the direction of rotation 1, 2, 3, 4, 5, 6. And I do end up at the corresponding points. So that confirms, that tells me that I have found the center of rotation. Now, that was a bit tough and not stated very well, so we're going to actually do it a couple more times. So the green one. So I'm going to connect the corresponding. I'm going to tell you right away that this is the center of rotation right here. So we're going to go through the steps and find out or see that the lines perpendicular to these line segments intersect at the center of rotation. So here we go. I'm going to connect the two corresponding points. So this point connects to this point, its corresponding point. This point connects with this point, its corresponding point. Then I'm going to find the midpoints. Using Doceri, I'm just going to draw line segments until they snap to each of these lines. I guess I didn't show you that. All right, so I find the midpoint, and then I draw a line that's perpendicular from this midpoint in this direction. And I'm just going to, actually, this one's a little bit easier because it moves right along these rhombus shapes. So it's pretty easy to see that that's perpendicular, but this one's not so easy. So you're just going to step down, just keep going down. You have to find an intersection. It has to cross, it has to stop at a point that's an intersection of the equilateral triangles, and it turns out it's the same common point as right here. So that is the center of rotation, that point right there. Let's prove it by counting. I'm going to count along the axis. This is the center of rotation. Well, this is along the axis, and it goes right to the points. This is 1, 2, 3, 4, 5. Then rotate 60 degrees. 1, 2, 3, 4, 5. And you end up right at that point right there. But this one is not along the axis. I'm going to count along the axis. 1, 2. And then in the direction of rotation, 1, 2, 3, 4, 5. All right, so rotate 60 degrees, count along the axis, 1, 2, and then 1, 2, 3, 4, 5 in the direction of rotation. So you do end up at the corresponding point. So that once again proves to you that you have found the center of rotation. Let's do it one more time. So connect the corresponding points. Connect this point with this point. Those points correspond. This point with this point, those points correspond. Then I'm going to find the midpoint. I'm going to use Doceri. I'm going to snap a line. It's going to snap right to the midpoint. And I'm going to use that. I'm going to step along until I find a line that's perpendicular. So it's going to cross. It's going to end at an intersection. And then I do it the same thing with this one. It's going to end at that same intersection. So it's down here. So this line is perpendicular. So how am I doing that? Well, I'm just starting here and I'm just kind of stepping through, looking at this intersection, this one, this one, this one, until I get to here and I can see that it is a right angle. You don't know for sure, and you might be off a little bit, and then when you check, you're going to find out that you're off, and you have to just move over at most one space. So I do it one more time. So this line this is a perpendicular line to this line segment. So now I'm just looking for an intersection that is perpendicular. So I'm just looking at this intersection, this one, until I get down to here. And that tells me also it intersects with this one. So this is the center of rotation right there. I'm going to check it by counting. So I'm going to count along the side of the equilateral triangle, 1, 2. And then in the direction of rotation, 1, 2, 3, 4, 5. So I'm going to rotate this 60 degrees, count 1, 2, and then 1, 2, 3, 4, 5. So you end up at the corresponding point. Do it one more time, 1, 2, 3, and then in the direction of rotation, 1, 2, 3, 4, 5. End up at that point. Now if I do the same counting, rotate this from here to here, 60 degrees. 1, 2, 3. 1, 2, 3, 4, 5. You end up at its corresponding point. So once again, it tells you that you have moved, you have found the center of rotation. All right, so I'm going to tell you, so what if they tell you up front, this is the center of rotation right here, and they want you to, the task is to rotate this image 60 degrees. So I'm going to draw a line that's perpendicular through that center of rotation. Then I'm going to look at a 60-degree rotation. Well, this is isometric grid paper. The equilateral triangles all form 60-degree angles. And halfway, if I go halfway, that's a 30-degree angle. Then another halfway, that's another 30-degree angle. So this is 60 degrees from this point to this point. So now how do I know where to place the image? I'm just going to count 1, 2, 3. And then I'm going to count this way. 1, 2, 3. And that image is going to get placed right here. So that is rotating that image 60 degrees. Draw a circle. These points all, actually this is, this pink line segment falls on that circle. And it rotates around. All right, this is the original problem. And this was the center of rotation that they said. So if I draw lines that are perpendicular to this line segment forming a 90-degree angle, go out 2 units this way, perpendicular, go out 2 units this way, is the point at which they intersect. Now if I didn't know that up front, I would connect their corresponding points, connect the corresponding points, and draw a line that's perpendicular to this line segment that connects those corresponding points. And then I look for where it's perpendicular with an intersection. So I would test this one. No, that's not perpendicular. That's not perpendicular. This one looks pretty good. And I've already told you, and we've already found this point. But let's say that none of that's there. So you're just trying to find that point right there. That one looks pretty good. You do that again with this one. So I would test this intersection here. No, that's not a 90-degree angle. Not a 90-degree angle. Actually, this is going in the wrong direction. So I test this one, this one, this one, and finally you get to here, and that is a 90-degree angle, and it also intersects with the first line segment. So this is the center of rotation. Draw a circle. These 2 back points of the trapezoid, both of them fall on that circle. So that's the center of rotation. Well, what if you're using grid paper instead of isometric grid paper, you're using regular graph paper? So I'm going to change this image just a little bit so all of these points fall on intersections. And I'm going to rotate this image 90 degrees. So it's going to go from here, and it's going to rotate 90 degrees to here. So rotate it 90 degrees. And so how do I find the center of rotation after that image has been rotated 90 degrees? So let's say this is given to you, and you have to find the center of rotation. Connect the corresponding points, and I'm going to draw line segments that are perpendicular. They're going to intersect at the midpoint, and they're going to be perpendicular to each of these line segments. So both of these are perpendicular, and they intersect at this point right here. So that is the center of rotation. Draw a circle. Then you can prove that that's the center of rotation by using the counting method. You count along the axis, 1, 2, 3, and then count in the direction of rotation, 1, 2. And if I do that on the same, so I'm going to rotate this 90 degrees, count along this axis, 1, 2, 3, count along in the direction of rotation, 1, 2, and I end up at the corresponding point. I do that again. This is going to get messy. I'm going to do that again with this point. So 1, 2, 3, 4, 5, and then 1, 2. So 1, 2, 3, 4, 5, 1, 2. Do that again with this point up here. 1, 2, 3, 4, 5, 6, and then 1 in the direction of rotation. Go to the axis that's rotated 90 degrees. Count 1, 2, 3, 4, 5, 6. And 1 unit in the direction of rotation, and then finally this pink, 1, 2, 3, 4, 5, and then you have to go back to this point right here, and 1, 2, 3, 4, 5. You actually have to go back to this point right here.